Hi there, this is Neha and welcome to my channel. So students, today we will discuss Bohr's model of atom. So Bohr's model of atom was given to overcome the limitation of Rutherford's model of atom. Okay, so what was the limitation of Rutherford's model of atom? See, what Rutherford told that the electrons are present in the extranuclear part and the protons are present inside the nucleus, which is a hard dense sphere. Okay, and these electrons keep on revolving around the nucleus just like planets are revolving around the sun. So it is quite stable. It is similar to the planetary motion of the electron, and the atom is quite stable. But the drawbacks came when Maxwell told that whenever a charged particle is moving with a very high speed in a circular path, it tends to lose its energy. Okay, this was a finding of the radiation theory by Maxwell. So electron is also a charged particle. It is also moving around a center in a circular path, so it should also lose some of its energy every time during its revolution. So every time when it is losing energy, it is coming closer to the nucleus. Okay, it is falling towards the nucleus. So now every time when this is repeated, so now the path of the electron is not circular, now it is the spiral one. Okay, it will come closer to the nucleus every time, and ultimately what will happen? Ultimately it will fall into the nucleus. Okay, but this is actually not happen because atoms are quite stable. So this becomes the limitation of Rutherford's model because he was unable to explain the stability of an atom. Okay, so what Niels Bohr told? Niels Bohr told that in his atomic model that electrons are not going to lose or gain energy when it is in a particular path. It revolves in a particular circular path, which is having a fixed value of energy, which are definite energy and are called orbits or stationary states. And in this state, it is not going to lose or gain energy. So this becomes the foundation of the stability of an atom. So let us just conclude what are the main postulates of Bohr's atomic model of atom. Okay, so what Niels Bohr told, that electrons are moving in a circular path around the nucleus, which are fixed in energy and are known as stationary states or energy shells or orbits. Okay, now these energy shells or orbits can be represented by notation like K, L, M, N or 1, 2, 3, 4 from inside to outside. Means the energy shell which is closest to the nucleus, it can be represented as K or 1, which is then after to this shell is L. Okay, and or 2. So likewise we are moving outside from the nucleus. Okay, now according to the energy of these shells, they are given their name. So how their energy are in order? The energy of these stationary states are in the order of increasing energy from inside to outside. That means K is having the lowest value of energy, then L, then M, then N, then O. Okay, like that. Or 1, 2, 3, 4 will go on increasing. This is the order of the energy of these circular orbits or energy shells. Okay, now whenever the electron is circulating in a particular orbit, it stays there. It is not going to lose or gain energy. Okay, so the atom is quite stable. Okay, now when this energy in the form of radiation is lost or gained by the electron, See, when the energy in the form of small packets, the definite value of energy is there when it is radiated or it is gained by the electron. Okay. So these small or discrete packets of energy are called as quanta. So in the form of quanta, the gain or loss of energy is occurring within the atom by the electron. Okay. Now, when it is happening, suppose the electron is in his particular state, particular energy shell, and it is provided with some energy, some value of energy. So what will happen? It will absorb energy and will jump to the higher energy state. Okay, and which is where it will be unstable, and after some time it will drop back to its original state. So in this state, the energy will be radiated and it will be the same amount of energy that is absorbed by the electron, okay, in the form of quanta. So this energy value between lower and higher state, okay, this is the energy difference between these two energy levels. Understood? So this happens. So the lowest energy state where the electron is quite stable, which is its original energy state, it is called the ground state, and the higher energy state where it is jumping and staying for some time and it is falling back, it is called the excited state. Okay, only when there is a transition between two energy state by the electron, then only the electron is going to gain or lose energy. Okay. Otherwise, in the ground state, it is not going to gain or lose energy. Okay, so the atom is quite stable. And the circular path, in this circular orbits, the electrons are revolving. So this is explained by Niels Bohr. Now, what are the limitations of this model? Now, the limitations of this model are that the electron, it is said that it is moving in a circular orbit. But actually, the path of the electron is not defined. It is not discrete. Okay. The path is probable. The position of electron, the nature of the electron is probable in nature. Okay. We can only talk about the probability of finding electron. We cannot just, know the exact position or velocity of the electron simultaneously. So with the electron is probable in nature. Okay, next thing is that the Bohr's model is applicable to hydrogen atom and hydrogen-like atom. That means the atoms that have only one electron in their energy shells. Okay, so this model is applied to only one electron system. In the periodic table, there are so many elements and all are having more than one electron. So there, the Bohr's atomic model fails to explain its nature. Okay, many of the properties of the atom it is unable to explain. Another thing is that how the atoms are combining, the chemical nature, how they are combining, and why the molecules are, so many molecules are formed at the result of chemical combination. So all the molecules are of different size and shape. So why this is so? Whereas the atoms are same, like spherical, okay, the nucleus and the extranuclear part, all atoms are spherical, but the molecules have different shapes. So how this happens? This is also not explained by Bohr's model of atom. There are more limitations which are out of your standard or out of your syllabus, which is really the part of study of higher sections. So that we will not discuss here. So that's all for today. If you like the video, then definitely like and share. Okay. So, and if you have any doubts, put your doubts in the comment box. Thank you. Keep smiling and keep learning.